continue with solution of triangles. Now let me tell you this, that this chapter, solution of triangles, consists many formulas, and so you got to remember them all. But what I'm going to do is, I'm going to mark many, some important formulas from that many, and you have to remember them, okay, to solve any question from this chapter. And in JEE, they just ask simple questions, just direct questions. You have to just apply the formula, and you'll get to the answer. Okay, and I will just mark some important formulas. Like, first of all, the thing that you have to remember for this topic, that is the most important thing, is that you have to make a triangle correct. Okay, so just make it an obtuse one. Always make this type of triangle to solve any question. Okay, let this A, this be B, and this is C. The side opposite to A is small a, side opposite to B is small b, side opposite to C is small c. Angle, this is angle A, this is angle B, and this is angle C. Always make this type of triangle so that you will never get confused. Okay, so first I will continue with the first formula of this chapter, sine rule. It is called sine rule. I'm just going to say to you that it's important or not important. I mean, you must remember them, or you should remember them. Okay, sine formula is A upon sine A. That is, this side upon the opposite angle is equals to B upon sine B is equals to C upon sine C is equals to K. We'll further denote it with 2R. Okay, we'll get to know this. Okay, so this is sine rule for this triangle. Now we'll deal with cosine rule. Okay, cosine rule, it says that cos of A. Okay, we are dealing with angle A here. So just remember this, that A will not come in the denominator and A will get subtracted in the numerator. For that, B square plus C square. So this is the formula for cos A. Similarly, for cos B, what will be it? In the denominator, B should not come, so A and C will come, and you have to subtract B square in the numerator. So what will come? A square plus C square in the numerator. Okay. Similarly, you can define cos C. Cos C will be what? C will not come in the denominator, and C will get subtracted in the numerator, C square. So A square plus B square minus C square. Okay, so this is how to remember cosine formula. This is sine formula, most important of all the formulas. Cosine formula, just remember one, and you can get to the other. That in this case A is there, so A is subtracted, and A is not in the denominator. Similarly, in this case B is there, B is subtracted, and B is not in the denominator. A and C, except B, A and C are there in the denominator. If C is there, then C square is subtracted, and C is not in the denominator. This is the way to remember cosine rule and sine rule. Okay, now the third one is projection formulas. Okay, they are also important, but they are not asked frequently in exams. B cos C plus C cos B. Okay, so this is A. B cos C plus C cos B, C cos capital B. Then small b will be what? A cos C plus C cos A. Small cb will be what? A cos B plus B cos A. You remember this? You can remember this. A is in this side, so A will not come here, and B and C will permute. Okay, so B cos C and C cos B. If B is in here, B will not come to this side. A and C will permute, A cos C plus C cos A. Similarly, A cos B plus B cos A for small c. So this is the projection formulas. Okay, we project actually in a triangle. That's why they are projection formula. I'm not going to derive any formula because you are not going to remember it that way, but you can remember it this way. Okay. The fourth formula is Napier's analogy. That's also called tangent rule. Okay, tangent rule, also called Napier's. Napier was the scientist who started it, and the formula is tan of difference of angles B minus C by 2. Let me just do this. Tan of B minus C by 2, that will be b minus c upon b plus c and 10 of a by 2. Okay, so you can see this. Now b minus c by 2 is on the left hand side. So b minus c will come here upon b plus c. B and c will be in the right hand side with a factor. And in the tangent you will have a, not b nor c. Okay, so 10 of a by 2. 10 of b minus c by 2. This is equal to 10 of a by 2 into b minus c by 2. So that's why b minus c into b upon b plus c. Similarly, you can write 10 of, let's just use one of the three. 10 of a minus b by 2 will be what? A minus b, because there is a minus b here, upon a plus b. 10 of what will be here? C by 2, because a and b are included, so there will be a c in here. Okay, now let's continue with trigonometric functions of half angles. Okay, trigonometric functions of half angles. Okay, so first sine a by 2, that will be root of s minus b s minus c upon bc. Fine. Similarly, sine b by 2 can be written as, what will be sine b by 2? Well, s is, let me define s. S is a plus b plus c by 2. That is the semi-perimeter of the triangle. Okay, you add all the three sides and you divide by 2, you will get s. So s minus b, that is semi-perimeter minus b side, semi-perimeter minus c side upon b and c. Sine b by 2 will be what? Semi-perimeter minus a side. You just ignore the a in here. Okay, so you will ignore b in here. So s minus c upon a and c. Okay, we have ignored b in this case. So similarly, you can write for sine c by 2. Second will be cos of a by 2. Cos a by 2 is what? Root of s minus a upon bc. Okay, in this you ignore except a. Okay, if you are having a here, so you will ignore except a, that is bc in here in the numerator. So you can write cos of b by 2 as, you will ignore of course b, so s minus b in the numerator, but ignore b in the denominator, so a and c. Okay, you will not ignore b in numerator but ignore b in denominator. Now from this you can just calculate 10 of a by 2 by just dividing sine with cos. That will be s minus b because of the sine, s minus c because of sine a by 2, then s minus a. The bc factor is common in both of them, so it will cancel out. So that's why this is the formula. Similarly, you can calculate the 10 of b by 2 and 10 of c by 2. 10 of b by 2 will be what? S minus a, s minus c upon s minus b. Okay, so this is the formula for 10 of a by 2. And this can also be written as, this is because you can, sine and cos. If you know sine and cos, then you can predict 10. But there is one more formula for 10. 10 of a by 2 is also given by a delta upon s minus a. I'll tell you how does this come. Delta in here is root of s minus a, s minus b, s minus c. Okay, s is the semi-perimeter, a, b, c are sides, and this is called area. 2 times area. Okay, this is the area of triangle. Now this is the not 2 times area, this is the area of triangle. Okay, this is the area of triangle. Okay, how does this come? When you multiply root of s minus a in the numerator, the root in the denominator will become a perfect square of a s minus a, and in the numerator you will get this term which is equals to delta. Okay, delta is this. Okay, this is not this. Delta is equals to this. So this is area of a triangle. Okay, now we'll move on with a further one important formula, that is given as sine of a is 2 by bc root of s minus a, s minus b and s minus c. This is also called 2 delta by BC. You got to remember this because this is one of the important formulae of this solution of triangles. Okay, so sine of A is 2 delta upon BC. So, or you can say from this, you can say delta is half BC sine A. Similarly, half CA sine B or half AB sine C. So this is, well, this is the most important formula, or you can write it like this. Okay, so delta area can be calculated as if you are given two sides and one angle, any two sides and the other angle. Okay, BC and A, CA and B, AB and C, then you can calculate the area of the triangle easily because half BC sine A is just half BC sine A. Okay, we'll move on further with area of triangle we have done. So we'll move on with MN rule. It is called MN rule. Well, just first we will make a diagram. Okay, this is the triangle. We'll always make A, B, C. This is our small a, or let's just not write it. Okay, now what we are going to do is we are going to make a line which divides it in the ratio m is to n, because MN rule is the division of a side in m is to n ratio. This angle we'll call alpha, this angle we'll call beta, and this angle will be theta. Okay, now this is not one of the important formulas, but you should know this. BD upon DC is given to you. This is D. Okay, BD upon DC is given to you as m is to n. Okay, if this is given, then m plus n cot theta will be equal to m cot alpha minus n cot beta. Okay, m cot alpha minus n cot beta will be equals to m plus n cot theta. Okay, or you can write it as n cot beta minus m cot c. Okay, you can write n cot b minus n cot c. I'm sorry, n cot b. Okay, this angle b and this angle c. Okay, m and n are these ratios, b and c ratios. So n cot b minus m cot c. Okay, either you can write it in terms of alpha and beta, or you can write it in terms of b and c, like this. So this is one of the formulae which is called MN rule. So you can remember this by MN. Okay, if you are talking about M and N, then B and C will come, or alpha and beta will come. Okay, you just have to draw the diagram and you will get to remember this. The eighth one is radius of circumcircle, which I used to denote in sine rule. Radius of circumcircle. Okay, now this is denoted as R, that is A upon 2 sine A, because the A upon sine A is equals to sine rule, which we can remember. A upon sine A is equals to B upon sine B is equals to C upon sine C, was equals to K or equals to 2R. So if that 2 comes down here, then it will be A upon 2 sine A or B upon 2 sine B. This is only the sine rule I am telling you. Okay, don't get confused. 2 upon sine C. Okay, now sine C can be written as, or sine A can be written as anything. So A, B, C upon, in terms of delta. Okay, this is the area of triangle delta, and A, B, C are all the three sides. So you can calculate the radius of circumcircle. Circumcircle is this circle. Okay, this is the triangle. Then the circle that that can be all the 3 points lie on the circumference of the triangle. Then it is a circumcircle. This is the center. Okay, so if all the 3 points of a triangle lies on the circumference of the circle, then it is a circumcircle, and the radius of that circle, this radius, capital R, is given by ABC by 4 delta. Okay, so and this is the thing. Now we are going to use the radius of incircle. Radius of incircle is small r is equals to delta by S. Okay, this is the radius of incircle. This was the radius of circumcircle, ABC upon 4 delta. This is the radius of incircle. R is equals to delta upon S. Okay, delta is the area, S is the S is the semi-perimeter. S is also known as A plus B plus C by 2. S is also known as semi-perimeter. Okay, R is the radius of small circle. This is called small r, this is called big R, capital R. Okay, so radius of circumcircle is this, radius of incircle. What will be our incircle in this case? This will be our incircle. Okay, so this radius is small r, and this radius, which is the big circle's radius, this radius is capital R. Okay, this radius is capital R, this radius is capital R. Fine. So small r and capital R, we must have a relation between them. There is, which is R is equals to 4R, 4 capital R, sine of A by 2, sine of B by 2, sine of C by 2. This is the relation between small r and capital R. 4R sine A by 2, sine B by 2, sine C by 2. Okay. Now R has two important formulas also. R can be written as small s minus a tan of A by 2. Okay. From the previous formula, let me show you tan of A by 2. This was tan of A by 2. Okay. This is tan of A by 2. Okay. So from this formula, what we conclude that s minus a tan of A by 2, it will be small r. Okay. From this formula, and of course from this delta upon s. Delta, you know, delta is root of s minus a, s minus b, s minus c. Okay. This delta upon s will be upon s. This s will come in the denominator. Okay. This will cut the s as root s, and you will have s minus a upon into tan A by 2 as r. This is r. Okay. Now, also it can be written as s minus b, of course, tan of b by 2 is equals to s minus c tan of c by 2. Fine. If you are using a here, then you will be using a here. If you are using b here, then you will be using b here. If you are using c here, then you will be using c here. This is s minus c. Okay. Now, R has one more important relation, but you don't have to remember this, because from the three upper formulas, this one, and this one, you can calculate any R. Okay. So it is A sin B by 2 sin C by 2 cos upon cos A by 2. Okay. This is the formula. A, if you are using A, then you will use sin of B and C and upon cos of A. Okay. So, and so on. Okay. I'm just writing and so on because this is not an important formula, but you can remember this. Okay. So, we'll move on to the radius of the X circles. X circles. So, R1 is equals to delta upon S minus A. R2 is equals to this is the important formula, and R3 is equals to delta upon S minus C. Okay. Now, what are R1, R2 and R3? First of all, what are the X circles? Okay. If this is A, this is B, and this is C, then the circle drawn on this side as the diameter is the C, that is R3. The radius of this circle will be R3.